Springs are fascinating objects that demonstrate the principles of physics in a tangible way. They stretch and compress, allowing us to visualize forces at work. Today, I want to guide you through a simple experiment that illustrates how adding masses to a spring causes it to stretch, and how we can investigate the link between force and extension. This experiment not only helps us understand the relationship between force and extension, but also allows us to calculate the energy stored in the spring when it is stretched. To begin, you will need a spring, a ruler, some weights or masses, and a stable surface to conduct your experiment. First, secure one end of the spring to a fixed point, like a table edge or a wall. This will ensure that the spring does not move as you add weights to it. Next, use the ruler to measure the initial length of the spring when it is not under any load. This is your starting point, and it's crucial to note this measurement accurately, as it will serve as the baseline for your experiment. Now, one by one, start adding weights to the free end of the spring. After adding each weight, measure the new length of the spring using your ruler. The difference between the new length and the original length gives you the extension of the spring for that particular mass. For example, if your spring originally measures 10 centimeters, and after adding a 1 kilogram weight, it stretches to 12 centimeters, the extension is 2 centimeters. Continue this process, adding more weights and measuring the corresponding extensions. It's important to keep track of the masses you are adding and their respective extensions in a table. This will allow you to see the relationship between the force applied and the extension of the spring. Remember, the force exerted by the weights can be calculated using the equation F equals mg, where m is the mass in kilograms and g is the acceleration due to gravity, which is approximately 9.81 atmas 2. As you compile your data, you will likely notice a pattern. As you increase the mass, the extension of the spring also increases. This relationship is linear for most springs within their elastic limit, meaning that if you were to plot your results on a graph, with force on the y-axis and extension on the x-axis, you would see a straight line. This linear relationship is described by Hooke's law, which states that the force exerted by a spring is directly proportional to the extension of the spring, as long as the spring is not stretched beyond its elastic limit. Now, let's delve into the energy aspect of our experiment. When you stretch a spring, you are storing energy in it, known as elastic potential energy. For springs that behave linearly, the energy stored can be calculated using the formula E equals 0.5 K x2, where E is the elastic potential energy, K is the spring constant, a measure of the stiffness of the spring, and x is the extension of the spring. To find the spring constant, you can calculate the slope of the line you plotted earlier. The slope is equal to K, and it represents how much force is required to produce a unit extension in the spring. Once you have determined the spring constant, you can use your measurements of extension to calculate the energy stored for any given extension. In conclusion, this simple experiment not only demonstrates the fundamental principles of springs, but also allows you to engage with the concepts of force, extension, and energy storage in a hands-on manner. By conducting this experiment, you gain a deeper understanding of how springs work and the scientific principles that govern them. So, gather your materials, measure carefully, and enjoy exploring the fascinating world of springs.